Hello everybody, I'm Cody, aka that Asian guy who isn't either Ethan or Akira. So, I'm talking about gravity. Now, I'm not talking about your grandmother's gravity. That's right, this isn't Newtonian gravity we're dealing with, it's Einsteinian. Okay, so I know not all of you are as cool as I am, so here's how Einsteinian gravity works. Imagine a giant net, sort of like a trampoline, but not exactly the same thing. That's the space-time continuum, basically the fabric of the universe. Imagine everything that exists. It's a tiny bit hard, huh? Well, everything that exists is a part of this net, the fabric of reality, if you will. Now, normally, this fabric, when it's got nothing on it, it's nice and flat. But as soon as we put something massive on it, though, like a cabbage, or me, or a small elephant, or a large mouse, the net curves just like it would if this wasn't a simulation and we had gravity. Also, by the way, by massive, I mean something having mass. Okay, so now imagine we have this net curved around a large mouse. A very large mouse. What happens if you roll a smaller object towards it, you ask? Well, good question, I say. Now, this smaller object makes a dent in the net too, but it's so much smaller than the mouse's, we're not even going to show that dent. Now, this smaller object is going to roll straight into the depression in the net, and that's going to give it an inwards acceleration. So, we've all learned about circular motion, and everybody remembers the rules, right? Of course you do, but just in case, here's a quick refresher. When an object moves in a circle, it has an acceleration towards the center of that circle. Same thing is true for our simulation. A smaller object will fall into an orbit around the large mouse. Now, one more last thing. If we place a stationary object at the edge of this depression, guess what happens? It'll roll down the slope straight towards the mouse. Smaller mass is attracted to the larger mass because the larger mass creates a larger dent in space-time. And that, folks, is all there is to it. There's no gravitons, no gravitational waves, no complicated explanations necessary. All you need is a trampoline and a very, very large mouse.